Myself Sarama Malik, thus Assistant Professor of Gargi Memorial Institute of Technology. In my previous lecture, I discussed about some special type of transformation of conformal mapping. Now today I discuss about bilinear transformation. Okay. Now what is bilinear transformation? A transformation of the form W is equals to AZ plus B by CZ plus D, where A, B, C and D are constant and AD minus BC not equals to 0 is called bilinear transformation. The transformation one can also be written as CWZ minus AZ plus WD minus B equals to 0, which is linear both in W and Z. Hence, the name is bilinear. Now, dW by dz is equals to AD minus BC by CZ plus D whole square, which is not equals to 0 everywhere except at Z is equals to infinity, and Fz is equals to Az plus B by Cz plus D is analytic except when Cz plus D equals to 0. That means Z is equals to minus D by C. So, the transformation 1 is conformal everywhere in the finite Z plane except at Z is equals to minus D by C. Okay. Now, there are some properties. Number 1, so some theorem, some deduction of this transformation. Number 1 is every bilinear transformation maps circles and lines into circles and lines. A line is also called a circle with infinite radius. Now, fixed point of a bilinear transformation. When a point coincides with its image under a bilinear transformation, then the point is called a fixed point or an invariant point. Now, theorem number 2. A bilinear transformation having exactly one fixed point is of the form 1 by w minus p is equals to 1 by z minus p plus k, where k not equals to 0 and p is the fixed point. This transformation is called parabola transformation. Next, theorem 3. A bilinear transformation having exactly two fixed points is of the form w minus p by w minus q is equals to k into z minus p by z minus q, where k not equals to 0 and 1 and p, q are the fixed point. Now here, this transformation is called elliptic if mod of k is equals to 1 and hyperbolic if k is real. So when mod of k is equals to 1, then this transformation is elliptic, and when k is real, then this transformation is hyperbolic. This is of equation 1 and this is of equation 2. Now, the transformation 1 and 2 are known as the normal form or canonical form of a bilinear transformation. Now, for example, say the transformation is W is equals to Z minus 1 by Z plus 1. We have to find out the normal form or canonical form. Okay. Then, for a fixed point, we have W is equals to Z. So, for fixed point, we put here W is equals to Z. So, from here, it will be Z is equals to Z minus 1 by Z plus 1, or Z square plus Z is equals to Z minus 1. That means Z square is equals to minus 1, or Z is equals to plus minus I. So the two fixed points are Z is equals to are I and minus I. Now W minus I there are the fixed point W minus I and W plus I. So from here we put that W minus I is equals to Z minus 1 by Z plus 1 into plus I. Minus I. So from this here, so from here it will be Z minus 1 minus I into Z plus 1 by Z plus 1, that is Z minus I into 1 minus I by Z plus 1, and W plus I is equals to Z minus 1 by Z plus 1 plus I. From this here, that is equals to Z minus 1 plus I into Z plus 1 by Z plus 1, which is equals to Z plus I into 1 plus I by Z plus 1. Yeah. So we find the value W minus I and W plus I. So from here, W minus I by W plus I is equals to Z minus I by z plus I into 1 minus I by 1 plus I. That can be written as k into z minus I by z plus I, where k is equals to 1 minus I by 1 plus I and is the normal form of the transformation. And now modulus of k is equals to modulus of 1 minus I by 1 plus I. That's equals to root over of 2 by root over of 2, that is equals to 1. Hence, the transformation is elliptic. Okay. Another example, say another theorem. Theorem number 4. The bilinear transformation which maps the points z1, z2, z3 of the z-plane into the points w1, w2, w3 of the w-plane respectively is w minus w1 into w2 minus w3 by w minus w3 into w2 minus w1, that is equals to z minus z1 into z2 minus z3 by z minus z3 into z2 minus z1. Okay, this is one types of forms. Now we illustrate some examples using these forms. Find the bilinear transformation which maps z is equals to I 1 minus 1 onto w is equals to 1 0 infinity respectively. Also so that the unit circle mod z is equals to 1 in z plane maps into the real axis of w plane. So from the transformation, let the bilinear transformation be w minus w1 into w2 minus w3 by w minus w3 into w2 minus w1 is equals to z minus z1 into z2 minus z3 by z minus z3 into z2 minus z1, where z1 is equals to I, z2 is equals to 1 and z3 is equals to minus 1, and w1 is equals to 1, w2 is equals to 0, w3 is equals to infinity. So as w3 is equals to infinity, so from 1 we have w minus w1 into w2 by w3 minus 1. We common here w3. That means w by w3 minus 1, w2 minus w1, which is equals to z minus z1, z2 minus z3, z minus z3, z2 minus z1. So from here w minus w1, that is 1, this is 0 by infinity, that is 0 minus 1, it is also 0 minus 1, w2 is 0 minus 1, that is equals to z minus I, z2 is 1 plus 1, z plus 1, 1 minus I. So from here 1 minus w is equals to 2 into z minus I by z plus 1 into 1 minus I, or from here w is equals to 1 plus 2 into 1 minus 2 into z minus I by z plus 1 into 1 minus I. So from here it is z plus 1 minus z I minus I minus 2z plus 2I by z plus 1 into 1 minus I, that is equals to minus z minus z I plus 1 by z plus 1 into 1 minus I. So if I common here minus z, it will be 1 plus I plus 1 1 plus I by z plus 1 into 1 minus I, that is 1 minus z into 1 plus I by 1 plus z into 1 minus I. If I multiply this one by 1 plus I, so this will be, this is 1 plus 2I minus 1, and it will be 1 a square minus b square formula, so this is 1. So from here I is common, I into 1 minus z by 1 plus z. That means w is equals to this. So which is the required transformation? Which is the required transformation? Now if I let w is equals to u plus iv and z is equals to x plus iy, we put it here. U plus iv is equals to I into 1 minus x minus iy by 1 plus x plus iy. That's equals to, again simplifying, by simplifying from here we can get, that is 2y by 1 plus x whole square plus y square minus I into x square plus y square minus 1 by 1 plus x whole square plus y square. It is u plus iv. So v is equal to minus of x square plus y square minus 1 by 1 plus x whole square plus y square. Therefore, when x square plus y square is equals to 1, that means mod z is equals to 1, then v is equals to 0. Hence, the transformation maps the unit circle mod z is equals to 1 into a real axis of w plane. Okay. Next day we discuss about another examples of bilinear transformation.